Okay, so welcome to our first installment of Fun with Vectors. Vector is not just a lovable cartoon character from Despicable Me who creates crimes with both direction and a magnitude. What does that mean? Well, let's get started. And it means you should probably watch Despicable Me. So, what we have here is a coordinate system. And we have the x-axis, we have the y-axis, and our degrees. So we start off, we have 0 degrees. If we rotate counterclockwise here, we have 90 degrees. We keep rotating, 180. We keep rotating, we have 270 degrees. So the quadrants here would be positive x and positive y, meaning in this area here, you have a positive value for x, you have a positive value for y. And then if we just carry on with that in this quadrant, so we have a negative value of x right here and a positive value of y. And then here we have negative x, negative y. And here we have negative y and positive x. So that's all reflected there. Now we're going to do these exercises. We're just going to keep it in positive numbers. But if we went the other way, we could express this in negative numbers. Here we would have negative 90 degrees, negative 180, negative 270, and then right back to 360. So just notice how here 90 is up here, and here we have negative 90. So it's just switched relative to our direction of motion, or rotation. So if we start off, we have our, and remember here, we have, this is our x. Right here is our x-axis, and this is our y-axis. So we have our graph. So grab yourself some graph paper and make yourself an x and y-axis. And I would say for the squares, maybe keep at least 2 squares to every one. So maybe 3, but either way, just stretch it out a little bit. Let it take up the most of the page. And we'll start there. So what we have here is I've given you 2 vectors. The u vector, I'm just giving these letter designations. There's nothing written in stone about this here. So the u vector, the v vector, and then the resultant. So what I've given you here is the Cartesian coordinates, what we would call rectangular. So the x and y. So I've given you a point where this magnitude is sitting at this point, sitting at negative 5 and 2. So at negative 5 on the x, and then 2 on the positive 2 on the y. And then the v vector is sitting 7, positive 7 on the x, positive 1 on the y. So positive 7 on the x, positive 1 on the y. And then the resultant vector is sitting at 2 and 3. So what I've done here is we're just going to add the vectors. So negative 5 plus 7 is 2, 2 plus 1 is 3. So the resultant vector ends up right there. So we have 2 on the x, 3 on the y. Now what you can notice is what we're going to do is we're going to use the tip-to-tail method for vector addition. And if you notice right here, so we have from 0, positive 7, positive 1. And if you notice, right from here, so if I start, the first vector was at negative 5 and 2, right from here. Now from this point, I have matched this magnitude here. Only I started it at the point where the previous one ended. And what I've done here is I've gone 7 over. Notice how it's in line with the 2, right? So the y is sitting at 2. The y is sitting right at 2 there. So I've just come straight across 7. And that lands on 2 there. And then up 1, which brings us to 3. And then our resultant vector, we just tie in right from the center right to the final point. And if you notice, here you end up with a parallelogram. So what this is here, so this vector has rotated from 0, from x, from 0 degrees here, it has rotated 158 degrees, or roughly 68 degrees past 90. So from 90, it's rotated. So from 0, it's rotated 158. From 90, it's rotated 68. So to solve for this, this is the way we're going to do this exercise. I'm going to give you the coordinates, and we're going to solve for the hypotenuse and the angle of rotation. So we're only going to use, we only need to use these two methods in this form, and we can solve for them. So the tan is equal to opposite over adjacent. So in this case, we have 90 degrees right here, and we have, this is the x-axis at 0, we have 90 degrees, and we have our vector, which is this right here, indicated by the arrow. So from 90 degrees, this has rotated 68 degrees. So because of this angle, this is now the opposite, which makes 2 the adjacent. So 5 to 2 gives us 2.5. Second function, our tan, gives us 68.2 degrees. So we know now this angle is 68.2 degrees. So the sine, opposite hypotenuse. So what we want to solve for now is the actual magnitude of the vector itself. What is the hypotenuse here? So the hypotenuse, we'll just switch everything around. The hypotenuse is 5 over the sine of 68.2 is what I got here. And we have 5.38. So we know that this magnitude is 5.38. So if we do that for the other vectors here, so we have the second vector, the v vector, 7 and 1. Now notice that from this point, it hasn't rotated far off the x-axis. We have only a few degrees in here. So here's the 90 degrees, here's the x-axis, 0 degrees, 1. So from this point, now because we're solving for this angle in here, the 1 becomes the opposite, 7 becomes adjacent. I'm just abbreviating everything in here as we move forward. Gives us 0.142, yada yada. Gives us 8.13 degrees. And then to find the hypotenuse, we have 1 over, gives us 7.07. So we know this has a magnitude of 7.07. So if we just continue on with the resultant vector, and all we've had to do is just add these vectors to find the resultant, but it's good that it all adds. It's always nice to double check our work. So if we continue on with the same, if you notice from x, this hasn't moved too far. So well, it hasn't passed 90, so we have 2 and 3. We're looking for this angle right in here. So from this angle, 3 is the opposite. So 3 to 2, 1.5 gives us 56.3 degrees. So the sine, flip it over, gives us a magnitude of 3.6. So we know this magnitude here is 3.6. So if we add these up, now we have, for the first one, 5.38, angle 68.2. Yeah, 7.07, 8.13, and 56.3 degrees, and a magnitude of 3.6. So now if we use our technique of, not our technique, but use our calculator to punch this in for, we use our polar function. If we input 5.38 angle 158.2 plus 7.07 angle 8.13, then we will get 3.16 with some decimals angle 56.3, or somewhere around 56.3. And that's the idea of this exercise, is to take rectangular coordinates, convert them into polar, and then use our calculators to double check the answers. But the tip-to-tail method is a common method for solving vectors, known as vector addition. So here now I've put one together, and we have the same method of solving. So we have vector number 1. Now what I suggest you do is pause the video, write this down, get your get everything plotted, your x and y coordinates, write down the x and y, and then try to reflect on the previous example, these examples right here. But what we have here is I started off -2, -5. So I started off with the red again. So now we have 4 vectors here, u, v, w, and z. And then we have our resultant. So if we add all these up, we end up with -4. If we add up all the y, we end up with 2. So if we start right here, we go down -5, -2 on the x. And that's what we have right here. So -5 on the y, -2 on the x. It doesn't really matter if you come down this way or that way. What you really have to understand is what angle you're solving for. That's why I've inserted these triangles where you can actually see the hypotenuse has rotated past 180 degrees to this point. If you draw these in the opposite manner, you'll be solving for the opposite angle right here, which would be this angle. So you can take 270 minus this angle, that works too. It doesn't matter to me how you solve it, but just know that there's 2 different ways to go about this. So we have the first vector, -2, -5, and then from here, it's just like as if you started from scratch. Right here, I drew the little crosshairs right here, as if you started right from here. So here now, we have +6 on the x and -1 on the y. And if you look at it, this would be your x-axis, this would be your y. This is 0 degrees, this is 90 degrees, 180, 270. So you have right here on the x, 6. So from here we're going to come, so we're at -2. So -2 plus 6 is 4. So we're going to come over here, and we end up right at 4. And then we're going to come down on the y, 1, -1. So -5, because we're at -5, plus -1 is going to give us -6. Now from here, it's as if we're starting right from scratch again. And if you look at these crosshairs, so now this is x at 0, y at 90. This right here is x at 180, and this is 270. So if we start right from here, we're going to go over -11 and -1 on the y. So 4 minus 11, we end up at -7 here. So 4, we're going to go back 11, and then down 1 on the y. So we have -6 minus 1 gives us -7. And then again, just to finish it off, crosshairs as if we're starting right from scratch. So right from here, we're going to go +3 on the x, +9 on the y. So you have from -7 plus 3 gives us -4. And we're -4 right here. We can come up this way. So 9, -7 plus 9 is going to give us +2, which brings up to there. And then come over, and we end up at negative 4.